Next slide. Now we're going to take a look at what's happening at the atomic level to produce the emission lines or the absorption lines. In the lecture outline, the first set of vocabulary terms is about the structure of the atom, and the second set of vocabulary terms is about the Doppler effect, which is what we use to measure the motion of something. We will use a simplified model of the atom devised by Niels Bohr about a century ago because it is easy to visualize. In Bohr's model of the atom, the massive but small positively charged protons and massive but small neutral neutrons are found in the tiny nucleus. The small, light, negatively charged electrons move around the nucleus in certain specific orbits, energies. In a neutral atom, the number of electrons equals the number of protons. The arrangement of an atom's energy orbits depends on the number of protons and neutrons in the nucleus and the number of electrons orbiting the nucleus. All atoms with the same number of protons in the nucleus are grouped together into something called an element. Because the atoms of an element have the same number of protons, they also have the same number of electrons, and therefore the same chemical properties. For example, all atoms with one proton in the nucleus have the same chemical properties and are called hydrogen. All atoms with two protons in the nucleus will not chemically react with any other atoms and are known as helium. Because every type of atom or element has a unique arrangement of the energy orbits, they produce a unique pattern of emission or absorption lines. If the rules of quantum mechanics and the strength of the fundamental forces of nature were even slightly different from place to place in our universe, the pattern of lines for the elements and molecules would be different from what we observe on the Earth. We know that the laws of nature are the same throughout the universe because everywhere we look, we see the same pattern of the spectral lines for all of the elements and molecules that we see in our laboratories here on Earth. Every neutral hydrogen atom has the barcode shown on the left, and every neutral helium atom has the barcode shown on the right. In order to explain the emission line and absorption line spectra, Bohr found that atoms obey three basic rules. Number one, atoms are very picky in that the electrons occupy only certain energy orbits in an atom and can be found nowhere else. Number two, the orbits closer to the nucleus have lower energy. Number three, atoms want to be in the lowest possible energy state called the ground state, where all the electrons are as close to the nucleus as possible. Let's see how Bohr's model of the atom explains emission and absorption lines. First, remember that the sum total of the atom's energy plus the light waves, or photons' energy, stays the same total value always. This is the universal law of the conservation of energy. So, if the atom absorbs energy from light, the energy of the light doesn't disappear from the universe. It goes into extra energy in the atom. According to the absorption line vocabulary term definition, when the atom absorbs energy, the electron jumps up or outward away farther from the nucleus. According to the emission line vocabulary term definition, when the atom emits or gives off a photon, the electron jumps down or inward closer to the nucleus. A big jump of the electron produces a spectral line of a shorter wavelength because a big jump means a large energy change, and photons of shorter wavelength have higher energy. Conversely, a small electron jump produces a longer wavelength spectral line. The energy of the spectral line photon equals the energy difference of the energy levels the electron transitions between. That's a subtraction or minus sign. Photon energy equals energy of the higher orbit minus energy of the lower orbit. Spectral lines of only specific wavelengths can be produced by an atom because the electrons can only be in an energy level and not in between. That's Bohr rule number one. The absorption line pattern for a given element equals the emission line pattern for the element because the energy levels are fixed. So the size of electron jumps outward must equal the size of the electron jumps inward. If an atom has extra energy, so its electron is in the second energy level orbit, E2, it wants to get to the lower E1 energy orbit. That's Bohr's rule number 3. Because of the conservation of energy, the atom has to emit a photon with energy equal to the energy of the E2 level minus the energy of the E1 level. Basic arithmetic. For the absorption line, you have a hot, dense object producing a continuous spectrum with photons of all wavelengths that then pass through the cooler thin gas. Zooming in on one of the gas atoms and focusing on 4 photons with just the right energy for the picky atom to absorb, photons with energy equal to E2 minus E1, one of the photons is absorbed and the other 3 continue on by. The atom remembers Bohr rule number 3 and gets rid of that extra energy by re-emitting the photon, but it'll be emitted in some random direction so that what we receive with our detector to the far right of the picture is just 3 photons instead of the original 4 photons. The atom totally ignores photons of the wrong energy, and they continue right on through the gas to our detector. So for those colors, or wavelengths, we detect all 4 photons. Imagine this happening for all those millions upon millions of atoms in the cloud, and you'll get the smooth, continuous rainbow with a specific color being dimmer or blacker than it would be if the thin, cooler gas cloud wasn't there. Let's do an example with a 3-level hydrogen atom on the left. The ground state first level has energy 3 EU energy units. The middle second level is 7 EU. And the outermost level 3 has energy 8 EU. What are the emission lines possible for this simple atom? Remember that you subtract energy levels. If the electron starts out in the outermost 8 EU level and hops down to the second 7 EU level, the atom will produce an emission line of energy equal to 8 EU minus 7 EU equals 1 EU. If the electron hops all the way down to the ground state in one big jump, the energy of the emission line equals 8 EU minus 3 EU equals 5 EU. If the electron starts in the middle level and hops down to the ground state, the emission line photon energy equals 7 EU minus 3 EU equals 4 EU. 3 emission lines are possible at energy 1 EU, 4 EU, and 5 EU. Real hydrogen atoms have more than 3 energy levels. For the helium atom shown on the right with 3 energy level orbits at 2 EU, 10 EU, and 15 EU, the atom will be able to absorb 3 photon energies. From ground state to middle level, the absorbed photon will have had energy 10 EU minus 2 EU equals 8 EU. From ground state to outermost level 3, the absorbed energy will have had energy 15 EU minus 2 EU equals 13 EU. From the middle level 2 to the outermost level 3, the absorbed photon will have had energy equals 15 EU minus 10 EU equals 5 EU. I created a more realistic example in the textbook with a "How do you do that" box. Check it out.